Jai Jayendra, Namaste and welcome to my channel. Today we are going to discuss the 48th question of the problem solving series and the last question of the stack, the 8th question of the stack. The difficulty level for this question is easy to medium, and this question has been asked in Amazon, Oracle, Walmart and many other companies. So let's look at the example. We need to implement queue using stack. So we have discussed queue, we have solved questions of queue. We have discussed stack, we have solved questions of stack, which is a last in first out operation. So whatever we put in the structure, if we pop the elements, it comes in the reverse order. That means the last data entered will go out first. But queue is just the opposite. Whatever goes inside in the beginning will come out. Let's understand queue using this example. Okay, so here in this queue we have this queue class form. So when we push an element to the queue, right? So what we push, this we push, right? 1. So this order is maintained. So 1 is pushed, then 2 is pushed, then pop. Now when we pop out from a queue structure, we will pop out the element which we have inserted first. So 1 will come out. Okay, 1. So 1 will be removed. Then what is the push? What do we push? We push 4. Okay, so 4 we have pushed. Next what do? We pop out. So if we pop out, the earlier we have pushed 2, right? So 2 will come. 2, right? And then again we pop out. So 2 is all we have to remove. And if we pop out, there is only one element in the queue, which is 4. So 1 to 4 will be printed. So first in, whatever comes in the beginning goes out in the beginning. First in, first out. Just like a line, right? So when you enter it, then you have to, if you are entering first, then you have to go leave first, right? So in the stack, it's the reverse. So how do we form a implement queue using stack, right? So if we have something, and if we so stack will reverse it, right? So if we reverse what is there in the stack again, then we get the original order, right? So here 1 to 4, when it is pushed in the stack, it gives us 4 to 1, right? But when again 4 to 1 will be pushed to the stack, then we will get 1 to 4, right? So these two things can be combined to form a queue, right? So whatever we push in stack 1, we will push it in the stack 2, and then we will again push whatever there is in the stack 2 in the stack 1, and then we will get our answer, right? So let's code this. So we will have two stack int s1 comma s2, right? So if say whatever is there in the stack 1, while stack 1 is not empty, right? What do? We push that into the stack 2. S2 dot push S1 dot top, right? And S1 dot pop. So whatever was there in the stack 1, we have pushed it into stack 2. Now we have a new element that is present in stack 1. So we will push that to stack 1. Stack 1 dot push x. Okay. Say we have 1, 2 already in the stack 2, right? And now 4 has come. So we have removed 1, 2. So 1, 2 was there in stack 1, and then we have pushed it into stack 2. Okay, so it becomes like this, and then we have inserted 4 again. And now 1, 2 have come. So what do? We'll insert back whatever has come into the stack 2, while s2 dot not empty. We will insert s1 dot push s2 dot top and s1 dot pop, right? And whatever, everything will be there in the stack 2. So right, 1, 2 was there, 4, and then when we push this one, right, so it would come in the order 2, 1. So it would be 1 to 4 again, right, if we pop out the elements. So 4 would be popped out first, it would be popped out from in the reverse order, right? So 1 would be popped out first, 2 would be popped out first, and then 4 would be popped out. What do we do in the pop section? If we see, so whatever was there in the stack 1, we have maintained only stack 1, okay? The outer world won't know about stack 2 operation, right? So whatever we push things into the stack 1 and we pop out from the stack 1, okay? So if S1 is empty, that means we don't have anything in the stack, right? If stack is empty, then we return -1, okay? Else we return S1 dot top. So we will pop out int x is equal to S1 dot top and return x. Okay, S1 dot top, S1 dot pop and return x. Got it? Let's just try run this. If we have a queue, okay, so in this queue we get elements as pushed 5, 10 and 15 has been pushed to queue, okay, and if we pop out it should give 5, 10, 15, right? So first, if everything is push, okay, so what happens in the stack 1, stack 1 is empty, right? So we will directly go here, and in stack 1 5 gets there, and stack 2 is empty, so nothing will happen. When 10 comes, okay, then we will insert, so S1 is not empty, so we'll insert 5 into the stack 1, okay, and then 5 in the stack 2, and then stack 1 becomes empty, and then we will push 10 in the stack 1, and then we will push what was there in the stack 2, which was 5, so we push 5. So again it becomes in this order 5. So 5, 5, 10. That means if we push return it from the top, so 5 would be returned, right? So this order is maintained. Again, when we get 15, so before going to 15, so we will pop insert whatever is there in the stack 1 to stack 2. So 5 would be inserted, then 10 would be inserted, right? Now stack 1 is empty, so in stack 1 we insert 15. So 15 is inserted in the stack 1. Now we will pop out whatever is there in the stack 2 to stack 1, stack 2 to stack 1. So in stack if 1 already 15 was there, then 10 would be pushed out, and then 5 would be passed out. So we'll have this 5, 10, 15. So when we will push things from here, pop out this, so we will get the order 5, 10, 15 as we should get as a queue. Okay, so I hope the explanation is clear. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 48th question, implement queue using stack. So you can see this example. My queue first 1 is pushed, then 2 is pushed, and then pick is means pick is printing the topmost element, and then we pop it out. Okay, so 1 is pushed, 2 is pushed, and when we pick it, so actually in pick it returns 1 because 1 was pushed in the beginning, and then it pops out, so we don't have anything so it becomes empty, right? Because 1 is pushed, 2 is pushed, and then pick, pop, and then whether it is empty or not. So this is so we have this 4 functions: push, pop, pick, and empty. If it is not empty, then we return false. Since there was 1 element left, 2 were pushed and 1 was popped out, so since it was left, so we are returning false. So let's look at the functions. Okay, so we have these 2 stacks, we have this queue, and in the push index, whatever is we have done, same thing we have done over here, and same thing we have done in the pop part also. In the pick part, that means returning the topmost element, the first element. Okay, so when it's in the queue 5, 10, 15 is pushed, so if we pick out, so first it was 5 was pushed, so 5 would be returned, and empty is check whether it is empty or not. Okay, so let's directly submit the code. So this has been accepted. So yeah, with this we come to the end of the topic stack. See you also in the next video. We will be explaining the 49th question of the problem solving series and the first question of Q. Jai Jinendra.